Thank you.
Let me suggest something that is deja vu for me. I mean, I saw this when you were first on, however long ago, 10, 12 years ago. Somebody wrote in and said he really wants to get behind what you're doing, um, like the idea a great deal, but why aren't, and we've discussed this long ago, why aren't more people or any other people getting these images? And the answer, you've answered it already. There are other
Yeah.
people getting these images.
Yes, yes, there are. I've sent you the email, Jeff. Way back in 2000 and the end of 2006 and 2007. I was in a safe house with transporting a VIP to
Uh-huh.
safety. And I was communicating with you then, and you were very kind and talked to me and kept lots of things in confidence. Basically, for instance, the Jerry Gilmore email, everyone can look at it. He clearly states him and me and his colleagues are doing exactly the same thing. And he actually quotes many astronomers around the world are seeing these
Mm-hmm.
satellites and objects in space, including the one that I mentioned to you last week, Jeff, which was the gentleman that now is the person in charge of Clay Observatory. And he was doing it way before me as well, Jeff. So, yeah, lots of people are seeing this. And again, I'm the only one who's been cyberbullied about it, which is terrible but not now. I only get the oddball, and that was the only one. Mainly, I've had wonderful response from lovely people.
Well,
You
very
know,
good. Now, I want to repeat one thing I said in our last visit,
yeah,
and that is the video that you had posted that showed at night you're sitting at your scope and someone was behind you taking a video at night of you with the view screen. It was I don't know, LED, or was a view screen, maybe three by four
that's right.
inches,
Yeah,
something like that.
yeah.
And
It's the flip out screen of the
on that
camera, Jeff. That's
LED
right.
screen was what you were imaging with the scope, and there was just a little tiny white dot. And as you racked that scope out and pulled that object in, it got bigger and bigger and bigger. And in real time, we watched that little tiny object of whiteness turn into one of these machines. And that's what they are. Are they satellites? Are they Star Wars? Are they stationary objects from some other planet? What are they? We don't know, but they're up there. And we watched you pull that up with your scope, and it filled your view screen, and I was just amazed. It was quite a demonstration. So that was something that was unforgettable about the early days. The other thing you mentioned last time, and I think you kind of let slip something you had always kept to yourself, about how you got that 8-inch telescope to perform such super incredible close-ups of the moon and other things as well. And you did it by taking would have been a video camera back then, I guess, but what are you using now? A digital camera? The idea was you would take a camera and use the lens on that camera to make the maximum image or near maximum image of your telescope get larger still. So you were able to compound the enlargement of whatever it was you were imaging with a secondary source.
Allegedly, yes, I'm going to stick to that because I don't want to be cyberbullied, as it cause trouble. Basically, yes, Jeff, you get a really nice camcorder. Back in those days, it would have been silly to take it apart, wouldn't it, for the common person,
Quite, yeah.
and anyone doing astronomy. But me, I got one, and I thought, what can I do? I've been looking through the lens part of it for ages, and so I just literally I'll be honest with you, Jeff. I got a screwdriver and poked the lens out to expose the chip, and this was a really nice camera, and it exposed the CCD chip down the barrel. So you imagine you get your camera, your hand camera, and look at it, and there's a lens. You have to poke the glass barrel in the zoom, and the barrel goes up and down. There's a secondary lens, and behind that there's a CCD chip. Now you can keep that there, but if you use your actual finger to still zoom, you can only go so far before the image would disappear, because it would not work correctly. But you can go a couple of notches, which give you that extra zoom, a few notches. Then I thought, well, let's poke that barrel out. So I poked the whole barrel and the secondary lens, which exposed the CCD chip. Then what you can do is get some very nice teleconverters. Now, these things times what you can see. Now, depending on the sensitivity of your chip and the size of your chip, you can get things that literally, like your magnifying glass that you use, Jeff, to look at the screen and in details. Yeah. You can actually put that in between the CCD chip that's in the barrel and your telescope. So, when you go to a back of a telescope, you normally look through a little eyepiece, don't you?
Sure.
Well, take that eyepiece out, and you're left with just the telescope empty. And if you used to look down it, you wouldn't be able to see nothing. So what you do then, you get your camera, and you've poked out your lens on your camera, and you've put one of these converters in between it. And my great friend is duct tape, tape.
Yes,
yeah?
Yes. Uh-huh.
I've got pictures, and you can see it's all taped on in the early days. You'd get your handy cam or whatever. You put your teleconverter, which is like a 2 times magnification part that would go in between. You have to put a little adjustment for your focal length, which is normally, on those eyepieces that you put in the telescope.
Yes.
You can unscrew the bottom of it. They come apart, and you're left with like a silver tube.
Okay. Yeah.
I don't know if you know, but astronomers listening,
I've seen an 8-inch Meade telescope up close. Yeah, and used it.
Yeah, and you get little eyepieces, don't you?
Yeah, several.
Yeah, and on those little eyepieces on the bottom, there's a silver bit that you push in, isn't there? A silver tube that's attached to the eyepiece.
Mm-hmm.
Yeah, on the bottom.
Mm-hmm.
Literally, you just unscrew that, use that, put that on there, tape it all up, push it into the eyepiece, and that then becomes not the lens, but the camera becomes, attached, and you can then use your little zoom, and that zooms in.
How ingenious! That's amazing.
And when I explained that to Jerry Gilmore, he said the same thing, and he explained that he was doing the same thing, but using BBC grade cameras, that they don't come with lenses. Literally, they unscrew the lenses, the ones, and they're big chips, yeah? And he was putting on massive telescopes with coolers and everything, and doing the exact same thing, and using, it's been around for a while, but there's this wonderful bit of software. There's other pieces of software that do the same thing, and there's a few other people out there that have just started doing it, that are using this piece of software called SharpCap. Now, SharpCap has got this wonderful little tool, and you go to the tool that says Zoom, and literally you can download this software for free. Go to sharpcap.co.uk. And this actual software is free. You can download it. It's got excellent PDFs to show you how to do it. What little, all the little things I've just told you about, webcams, how you can modify them to do what I've just told you, what webcams are compatible with this software and what cameras are. It's brilliant software. And there's some people using it. In fact, one of these cyberbullies are using it now, and they're, zooming into the moon, And what you do, you get the zoom, and what it does, it lets the software zooms into the chip, so it doesn't distort. You can do it live and broadcast it, so it appears that you're zooming in, but what you're actually doing, you're actually just zooming into the chip, which the chip is seeing the whole moon still, but the software is zooming into that part and broadcasting it live. Does that make sense?
Fascinating.
Very clever. And as I said, Jerry Gilmore and me were doing this way back, 10, 11 years ago.
Mm-hmm.
And a lot of astronomers were, and doing it even before me and Jerry Gilmore, this chap who's now the head of Clay Observatory. It's a wonderful hobby.
This will work on anything that the scope can image. Anything.
Well, the bigger the chip that you use, the better. Yeah. The better quality chip you use, like a full frame one, like a Canon or a Nikon, or even go to I use a Sony A7 and a Sony A7S, and they are 42 megapixels. They are brilliant, and I've been using. I was one of the first people in England to get a Sony A7S. The company was so kind, and I've used other things like a Fuji S Pro 1, which is a dedicated UV telescope. And I was one of the first people to have that in the country. I had to sign a disclosure and also promise with the company, I had to promise not to use the Sony Pro F1 for certain matters, which I never will. I expect to explain it's for astronomy. They were fine with that. I've still got the document. I could send it to you for the people that are listening. And basically, the bigger the chip, the more better resolution. You can zoom in with this wonderful free software. It's amazing, Jeff. There's no trickery. It's all real. And can tell the way I'm talking. It was wonderful when I've ground 3,400 and something millimeter focal lengths. So they actually, like, that's a 14-inch one, are quite good to start with. But then when you add the ×2 on the back, which is a teleconverter, it sort of doubles it. Sort of attempts to, but it goes a little bit duller. So what you have to do, you have to find equipment that will intensify the light that's coming through your telescope, and the ×2 teleconverter. Once you've hit that sweet spot, getting the higher resolution cameras, the better megapixels, and the better intensifiers, you can then do what I've done to get really close. You can buy off of a wonderful company a 5x teleconverter, or expander. For the people that don't know what it means, it expands the view 5 times. So it's a very high quality, nice piece of equipment, and it literally is all really nice pieces of glass that literally, like your magnifying glass, you've got like 5, or some come with 7 elements, or 3 or 5. So it's like 5 little magnifying glasses, all separate, different intervals, to give you a really good, very close-up image. Yeah. But the trouble is, the more elements you put in, the more glass, which are elements you put in between your CCD chip and on the back of the telescope, the duller the image used to be, until you buy something like a Sony A7S, which the ISO range can go up to 450,000 ISO, or just about around that approximate area. And the good thing is, the old cameras, which were like Nikon and Canon, used to only, in video mode, go up to like 6,000, 8,000 ISO a push.
Right.
So you couldn't really push your boundaries through the elements. You couldn't put much glass between your CCD chip and the telescope. So what you have to do, you have to find either Gen tubes. I started putting Gen night vision tubes. I was buying off of a very amazing company called Starlight Night Vision in UK. They're a wonderful company, very helpful, and you can ask them, can I please have just a tube, a Gen tube, and they sell small little ones that fit perfectly into the eye bed pieces of telescopes.
Wow.
Which is amazing, and that will intensify what you're seeing in space. So you imagine you put one of these Gen tubes first, then your eyepieces, and then what you can do is get another Gen tube and put it on top of the eyepieces, and you can piggyback these Gen night vision tubes to intensify each other, which is incredible, which I've been doing. And they know this, and they've been, selling this without people knowing. Well, they know now. And, then you put your camera on top of that, and you can see through 5 elements. Now, if you want to get better, I've actually gone beyond that and put a combination of elements of actual beautiful pieces of glass, which I've had specially made for me by Orion Optics. They are a wonderful company. Orion Optics is in Wales in UK, and for people